atoms are far too small to be seen directly. So how do we know that they exist? The Shedding Light on Atoms series brilliantly answers this question. In Shedding Light on Atoms Episode 2, Oxygen Everywhere, we discuss how the discovery of oxygen helped to accelerate the study of chemistry. We examine how hydrogen was discovered and how it was discovered that water is formed when hydrogen and oxygen chemically join together. We then look at oxygen's role in producing metal oxides from metals and its role in respiration. The history of the discoveries relating to oxygen is blended in seamlessly with modern chemistry to give students a really strong foundation in the scientific method and in the steps which led to an atomic theory. The program comes with a set of notes and a worksheet for students. Here's a quick excerpt.
In the 1760s, English scientist Henry Cavendish was experimenting with metals and acids and discovered another gas which was different again. We'll create this gas by reacting magnesium metal with hydrochloric acid. Like the two reactions we saw in episode 1 that produced CO2 and O2, this one also produces bubbles of gas as soon as the two chemicals come into contact. Henry Cavendish used zinc in his experiments, but I'm using magnesium because it reacts a little faster with the acid. This time, we'll collect the gas by allowing it to bubble up through some soapy water. As the gas is produced, it passes through the tube into the soapy water and it's trapped inside the tiny bubbles which form. This gas is not like oxygen, which supports fire. It's actually flammable. In 1783, it was named hydrogen. Now the oxygen needed for the fire to burn comes from above the bubbles. However, if we bubble hydrogen and oxygen into the soapy water together, so that the hydrogen and oxygen are right next to each other, the hydrogen burns even faster. Explosively, in fact. Here's another take. Whoa. When we examine the video frame by frame, we can see the flash of light created by the burning hydrogen. What we don't see is any smoke, because when hydrogen burns, the only product is steam, which eventually condenses to produce liquid water, pure, normal, everyday water. To show you the water forming, we can also collect hydrogen gas in a dry upside-down test tube and then ignite it. It's very hard to see, but the inside of the test tube is now a little misty because some of the water that was produced in the reaction has condensed on the glass. Here's the video frame by frame. The hydrogen burned really quickly, producing a small flash of light and a popping sound. The word hydrogen in fact comes from the ancient Greek words hydro, meaning water, and gen, meaning generator or producer. Hydrogen generates water when it burns. The chemical equation for the reaction that produced the hydrogen gas can be written as magnesium plus hydrochloric acid produces hydrogen plus magnesium chloride, which once again we couldn't see because it remained dissolved in the acid. In symbols, we can write Mg plus HCl produces H2, the hydrogen atoms in hydrogen gas always come in pairs, plus MgCl2. This equation is unbalanced because while HCl is made of one H atom and one Cl atom, the products on the right show two H atoms and two Cl atoms. To balance the equation, we need to put a 2 in front of the HCl. The chemical equation for hydrogen burning is hydrogen plus oxygen produces water. H2 plus O2 produces H2O. This equation is also unbalanced. One of our original oxygen atoms seems to have disappeared. In fact, 2 H2O molecules form for every one pair of oxygen atoms. Now though, we have 4 hydrogen atoms on the right-hand side, so we need another pair of hydrogen atoms on the left-hand side to react. The balanced chemical equation can therefore be written as 2H2 plus O2 produces 2H2O. Now, when performing their experiments in the late 1700s, they didn't use bubbles to trap gases. Their discoveries were made possible by the use of high-quality apparatus that could, for example,